Welcome everyone. Sorry for starting a little bit late. Break times and the first sessions and things were running a bit late. So yeah, we'll see if we can make up some time as we go through. Just to introduce myself, my name is Jamie Gillespie. I'm a senior security specialist at APNIC. So the work I do at APNIC is mostly external facing security. So doing a lot of training, capacity development, speaking at conferences like this one as well. So yeah, hoping to share some of my knowledge. I've been working in dedicated cybersecurity roles for about 23 years now. Before that, working for a backbone internet provider back in Canada. And before that, studying electronics engineering. So this session is going to run a little bit different. This session is going to be a choose your own adventure style. So what we have is actually a bit of a poll. So let me bring this up 1 second. And you'll need your phones in order to do this. There we go. So this one is using a tool called Mentimeter. Mentimeter is a online poll interacting website. Up at the top is a code, but if you scan the QR code, you'll be able to get to it as well. Let me see if I can bring that up. So the code here is 81416408, and you just go to menti.com. Or scanning the QR code will do it. It's just this one question, so you can do this on your mobile devices, you can do this on your laptops if you wish as well. Everyone who's joining remotely is free to join as well. And what we're doing is we've got a list of, what is it, about 12, 13 different security topics. And this is basically depending upon who actually turns up in the room, you guys get to vote on which 3, 4, maybe 2, depending upon how long they are, how many topics I actually discuss. So rather than me putting forward a list of just 2 or 3 topics and then doing that, it's dependent upon you who's actually in the room, who decided to come to this session instead of other sessions, that you get to choose what is going to be talked about. Now, the Mentimeter voting, you have 100 points, and you can distribute those points across different topics, or you can put all 100 points onto one topic if you're really passionate about that one topic. So yeah, so we'll give everyone just a few minutes to go through and do the voting. Again, if you're joining without scanning the QR code, you just go to menti.com and put in that number code up at the top there, the 81416408, and that will let you do the voting as well. So for the people that weren't scanning QR codes using their laptops or something, you just go to menti.com and it will give you a point where you can type in a number, and that's where you put that number in there. Unfortunately, yeah, when I zoom out, the number gets very small, so makes it a little bit harder to view. And remember, you've got 100 points, so you can spread it out if you wish, or you can throw it all onto one topic. Looks like someone threw all their points onto DDoS attacks and countermeasures. Okay, I'll just give another couple of minutes, and then we'll see what the final winning is. Okay, so let's zoom out and let's see where the voting is taking us at the moment. So things are still moving around a little bit. So DDoS attacks and countermeasures is up at the top. Security basics and definitions is up there. Threats, countermeasures to confidentiality, integrity, and availability is in third. Security policies, frameworks is fourth, and operational SMTP, TLS. Excellent. Okay, well, I think the top 4 are going to be it. Have you submitted the points? Almost there. It's a lot of topics to choose from. So yes. Okay. Anyone else putting in points and voting? Okay. So the ones that we have here, we're going to start off with DDoS attacks and countermeasures. We'll then go through a presentation on security basics and definitions. And depending upon time, we'll go through threats, countermeasures, and operational security. So yeah, thank you very much for participating in the Choose Your Own Adventure for this. These ones down here are interesting as well. If I had the whole day for this session, I could go through and do a lot more. But yeah, the people in the room get to vote, and you have chosen. So let me go through and have a look at this. Also, one other thing, as we go through the presentation, my email address is in the schedule app. I think my LinkedIn profile is in there as well. Please ask questions as we go through. We've got other microphones that can be brought around if you have questions. But I'm here for the week. Feel free to catch up with me, have some conversations about what was discussed, or maybe things that weren't discussed. Okay, so let's start off. It was DDoS first off, eh? There we go. Okay, so DDoS attacks and countermeasures. There we go. Okay, so topic on DDoS attacks and countermeasures. I'll go through it fairly quickly so we can get on to the other topics as well. Basic definitions: denial of service is looking at any sort of an attack that can reduce the availability of that service or denying access to the service. And a DDoS, or distributed denial of service, is where you have multiple points that are acting as those denial of service connections from there. So DDoS is, of course, the one that most people are familiar with. This is the ones that are large packets per second, large bandwidth attacks. But regular denial of service is a very real attack. It only comes from one source. So it's not to say that this is more damaging than this. If both of these can deny legitimate users access to your service, then they both have the same impact. It doesn't matter how the attack is performed. It matters what is the impact on your business, on your services. So users see DDoS attacks as the outage. They don't know what's causing the outage. Maybe it's your servers are shut down, something rebooted, something along the middle of the connection had problems. But the users are going to be seeing it as that outage. If you have a security team within your organization, the security team looks at this from that confidentiality, integrity, and availability, that CIA triad, which is one of the other topics to talk about today. And they see that as that loss of availability. These are the three core tenets of cybersecurity and information security. But then when the business management are seeing DDoS attacks, this is impacting business. And this is usually the reason why a lot of DDoS attacks are performed, is because it's going to be damaging the business that is trying to provide the service. Especially if you're an internet service provider where providing internet access is your core business. If you're processing credit cards, if you're taking in money for services, all of these things are going to be then impacting the business and the revenue being brought in. So DDoS attacks are largely grouped into a couple different categories here. So the first one is probably the most popular: bandwidth exhaustion. This is where the attacks are sending so much volume of traffic that it's using up all the bandwidth of the upstream connections, and therefore legitimate traffic can't come through. But just as serious is connection exhaustion. Connection exhaustion is where it's very small pieces of packets, but it's using up all the available connections in the connection table. And this could be anywhere along the path that has a connection limit. Usually it's the server side of things, where the web server itself can only have so many active connections at one time, but it could be further up the network scale as well. The connection exhaustion is a little bit harder to see on bandwidth graphs because they are connections as opposed to large packets taking up bandwidth. And of course, the last one is targeted exploitation. This is usually more of that single source denial of service, but targeted exploitation can crash, reboot, and hang services along the way. This targeted exploitation does not require large botnets and other connections like that. This can be done from single sources. Now, when we look at the ways of denial of service attacks, we break it down by layers and looking at what services are running on each layer. And then from there, what attacks can be done along that way. So starting down at the very bottom here, this is where we've got the network access layer. I do prefer the TCP/IP model as my personal preference because the OSI model is for books. And the TCP/IP model is how the internet actually works. So the network access layer here, this is where we're running Wi-Fi, Ethernet, copper. Some of the attacks along here is Wi-Fi deauthentication attacks, jamming, electrical interference, and of course, construction equipment. If you've ever had the backhoe that digs up a fiber optic cable, that is a denial of service attack. That piece of machinery has broken a fiber optic connection or many of them, therefore denying the service that that cable provides. So it's very physical down at the low level. At the internet layer, this is where we have IP, ICMP, as well as some old routing protocols like RIP. There isn't a lot of DDoS attacks that are taking place here. ICMP floods exist. They're not very exciting. They aren't very effective as far as denial of service, but it is a thing that does take place. Up at the transport layer where TCP and UDP are operating, the only real type of attack for DDoS that we have here are SYN floods. And the SYN floods is where we're looking at that connection oriented. A SYN flood is where it's not finishing the three-way handshake, it's sending the SYN, receives the SYN-ACK, and then just stops, does not finish the connection. So these are very small packets. That three-way handshake is just flags on empty packets. So the amount of bandwidth being used is very small, but it can consume a connection table and fill it up very quickly. And up at the application layer, this is where all the exciting protocols take place. Web, file transfers, time, DNS, all of these things are taking place at the higher layer, and this allows a lot of really interesting attacks to take place. We're going to talk more about reflection and amplification, but that's your traditional bandwidth DDoS attacks, as well as some other interesting ones, SIP flooding attacks for going after VoIP systems, complex database queries where you can actually go through a web server and chew up resources on the database server behind it. By tricking the web server to send complex queries to the database behind, you can actually overwhelm the database and chew through disk and memory and CPU, thus making anything that uses that database unavailable or slow to respond. So if we purely look at bandwidth style of attacks, we can see a progression of how much traffic has been going through over the years. We go back 12 years to 2012, we were seeing the largest attacks at that time was 60 gigabits per second. That's still quite large for a lot of people. That's large for a lot of countries even today. 1 year later, it increased 5 times. That was the attacks against Spamhaus, the spam blocking system, 300 gigabit attack. Year later, up to 500. 2 years later, up to 1.2 terabits, 1.3, 1.7. And finally, some of the largest bandwidth attacks that we were seeing was 2.3 terabits per second. And that was against an unknown AWS customer at that point. What we're also seeing at the same time is requests per second. These are ones that could be bandwidth related, but it's specifically a number of connections. So connection table style of attacks. And what we're seeing here, Cloudflare a few years ago got 17.2 million requests per second against their customer base. So Cloudflare's business is about absorbing these types of attacks, but this is the type of thing that could be directed at any one point on the internet. So 17.2 million requests per second. Google got 398 million requests per second just last year. That's another interesting one. Of course, they're large going against these customers or these systems that can absorb them, hopefully. But again, these types of attacks could be directed against anybody on the internet. It's not always against the large content distribution or cloud scrubbing systems like AWS, Cloudflare, and Google. Now, one thing that can sort of provide a little bit of comfort, not everybody gets these attacks thrown at them. The average report or the average reported denial of service attack is only between 1 and 25 gigabits per second. I say only, but that's still a lot of traffic being sent at your servers. And they usually only last less than 4 hours. sometimes as short as 5 or 10 minutes. And, some of these attacks are a bit more sustained. The main thing, of course, is going after that disruption to the service. And some of these are actually ransom style of DDoS attacks, not ransomware, but ransom attacks that they would actually send a short burst of traffic for about 5 or 10 minutes. You notice it on your network, and then they stop and they send you an email and say, did you see that? Did you feel that? We did that, and we're going to do it again unless you pay us money. This was a popular one probably about 7, 8 years ago, DD4BC, DDoS for Bitcoin. It was an interesting hacker criminal group, and that was their primary motive. They would go in, they would do a short attack, they would then email, ask for money. If you don't pay, they do a longer attack, and then they say the price has gone up. And every time you don't pay, they do another attack for longer, and the price goes up and up and up. And they actually use news reports as part of their email to you saying, hey, do you see these past DDoS attacks? That was us. If we can do that to other people, we can do that to you as well. So this sort of extortion ransom for DDoS is a very real thing. So let's break down DDoS attacks and see how they actually work if you've never seen one in action. So if we go to a very plain, simple denial of service attack, this is usually where there's some sort of vulnerability on the victim's servers. And we have the attacker, and they basically send traffic from one source to one destination, and that somehow either crashes or reboots or overwhelms that single server. This can be as simple as this person having a 1 gigabit per second network connection and this person having a 100 megabit internet connection. If this person can have more bandwidth than that person, then they can cause a simple denial of service attack. Similarly, if there's vulnerabilities on that other side, they can just exploit a vulnerability and then take over control of that server, crash it, do whatever they wish. So when we look at distributed denial of service attacks, this is where we have extra pieces in the middle. So instead of the attacker sending connections and sending traffic directly, they're using a botnet. So a botnet is a collection of compromised computers that have malicious software on it that allow the attacker to remote control them to do whatever they want. I'm showing 5 here. Large botnets that I've seen years ago was in the realm of like 500,000 computers in one botnet. That's all controlled by one person or one group. It's very difficult to manage a network of 500,000 computers. So usually the botnets were coming down in size and having multiple of them around. 100,000 computers here, 50,000 computers here, maybe 200,000 computers there. And managing those and redirecting their traffic that way. So the attacker sends one command to the botnet. So this one command to a large group of computers, and then that large group of computers does whatever it says. Maybe sending valid traffic requests. Could you and your network handle 100,000 computers visiting your website at exactly the same point in time? That's a lot of connections at one exact point in time. Usually normal traffic is spread out, right? So this could be legitimate traffic. This could be, of course, invalid traffic as well. Sending large fake packets to ports that are closed, maybe UDP, and it can just throw a lot of traffic, chewing up a lot of bandwidth. And then the way that most DDoS attacks, for bandwidth at least, are taking place now is reflection and amplification. So we still have the attacker and we still have the botnet. And the attacker still sends one little request to the botnet, but we have a few extra pieces in the middle here. Now I'm using DNS as the example here for how this is done. You can use NTP and other UDP-based protocols that I'll talk about later, but here we're using DNS. So here we have open recursive DNS servers. These are not under control of the attacker. These are DNS servers out on the internet that are misconfigured, allowing anybody to use them for recursiveness. Now, Google runs 8.8.8.8, Cloudflare runs 1.1.1.1, but they have limits on those servers to prevent them being used for attacks. But those are open recursive servers. A lot of internet service providers will provide their customers with recursive DNS servers that are misconfigured to allow anybody on the internet to use them as well. Now, DNS is a UDP-based protocol primarily, which allows it to have spoofed source addresses. There's no three-way handshake. You can redirect packets and throw the responses anywhere you want on the internet. So the attacker knows where these exist. You can search for them using Census, using Shodan.io. You can find open recursive DNS servers. There's thousands, tens of thousands of them on the internet, all contributing to DDoS attacks. Now, these botnets then send DNS requests to these recursive DNS servers. Now, there is something that the attacker does have control over, and that is an authoritative DNS server. So the attacker creates a domain name. In this case, we're just using evil.com as a fake domain, not the real evil.com. And they create a text record that is 4,000 bytes long. So these bots are requesting these open recursive servers for this text record. Now, the authoritative server replies back. So small request, and it responds with the 4,000 bytes, a big fat packet of data. Now, this is now being cached, okay? So recursive servers cache their responses, right? So down here, this doesn't need a lot of traffic. This is just a regular server somewhere out on AWS or Google or wherever. And then we have the victim. Now, the victim's over here. The bots are sending requests to the DNS servers. They're spoofing the source address, saying, hey, I want this text record, and send it back to me at 10.10.11. So the responses come back. So you can see small little requests go out and very large responses come back. Now, if you have 100,000 computers here and you have 100,000 DNS servers here, it all gets multiplied. Because one of these bots, one computer here, can send their request to multiple DNS servers. So while you have a lot here, you have a lot there, it gets multiplied through, then the traffic gets amplified as well, because it's a small request for a DNS record and a very large 4,000 byte reply. This is how you get 2 terabits per second of DDoS traffic. So UDP is spoofable. You can create forged source IP addresses because there's no three-way handshake. You can send any request on UDP, fake where the source address comes from, and the reply will go off to someone else. For amplification, you need a service that runs on UDP that accepts a small request and then will give a large response from there. So these are some examples of bandwidth amplification factors. So DNS that we're talking about here, you can get up to about a 54 times multiplication. Over on the other side, we have some other interesting UDP protocols. Chargen, or the character generator. This is never, well, not usually open on the internet anymore, but it is very large. NTP, if you're running a time server that is running an old version that has a vulnerability in it, it allows you to send a small request and get back a large response of every client that has been talking to the NTP server. Then you had vulnerabilities in Memcached. Memcached had a weakness where you could actually upload a file to it, 1 megabyte, 2 megabyte file, and then over UDP request that file to be sent back to you. And because it's UDP, you can change the source address, and you can then tell the server, send 1 megabyte files over to the victim. That allowed an amplification of 51,000 times. So if you had a 1 megabit per second connection and you were using 1 megabit per second of requests, you could get 51 gigabits per second of traffic out of that. As an example, this is not even using specially created DNS records. This is just purely regular internet. So here, doing a request for 8888, from there, you can see that the request is quite small, 80 bytes long, and the reply is 372. Another one here, I'm doing a DNS request for any record on Microsoft.com. So I send a very small request, 73 bytes, and I get back this large block of text. This isn't even created for attacks. This is just using other domains that exist. So you can see that amplification factor right there. Now imagine that it goes from 73 to 4,000, and you can see that large difference. So mitigation strategies. To protect your servers from connection exhaustion, so not bandwidth attacks, but connection exhaustion, this is where you need to look at your connection tables. You need to look at your TCP/IP stacks and seeing how they are handling a large number of connections. So some of the examples here is either reusing of connections or time waiting delays. If a connection has been finished, sometimes by default, operating systems will keep that connection in the table for up to 5 minutes. You don't need to keep those sorts of connections for such a long time, especially if you know that the traffic has finished at that point in time. You can also use TCP SYN cookies. So the SYN cookies is, instead of doing the three-way handshake and keeping it in a table, it uses some math, it uses sequence numbers, and it basically inserts a unique number into the sequence number, and then it waits for the sequence number to be incremented by 1, because the next the next packet in that connection would be incremented by 1. It waits for that to come back. So instead of using a connection table, it's waiting for a special number, a magic number to come back to finish the connection. Going up from the TCP/IP stack, there's some applications that can be configured differently or replaced with other applications that don't hold on to connections in different ways. So the slow LoRa's attack was going against the Apache using NPM modules. And it's basically the way that the connections were being requested that it could hold a connection open with an Apache web server. Nginx is not vulnerable because it uses a different type of connection processing. So yeah, this is just an example for that. Other examples is configuring your mail servers. SMTP servers have been attacked as well, where again, a lot of connections are made and then they hold them open without sending a lot of traffic. So you can actually cause a denial of service against the mail server in the same way that you can do it against web servers here as well. Now, other things that you can do for your network and your services, of course, have DDoS filtering. Sometimes you'll have the fancy, next-gen firewalls. They may have some DDoS filtering capabilities installed in them. You may have intrusion prevention systems that may be able to look for specific DDoS traffic, but that will only work if the traffic is malicious. If it looks legitimate, if it's 100,000 computers requesting your homepage all at the same time, some of these services may not pick up on that because it looks like a legitimate 100,000 customers coming to your website. You can, of course, then go for load balancing. Load balancing allows you to distribute if it's an attack against your web server. By having a load balancer, you can run up more servers behind it. Of course, if you're off in the cloud system, you can do automatic scaling and elastic growth for that. So configuring that and having that tested and working is another way that you can bring up more resources to handle that load. And on the web servers themselves, you can also have web application firewalls. Web application firewall is filtering, looking for different types of attacks, usually things like SQL injection and cross-site scripting, but that can look for specific attack traffic. Web application firewalls can run in central network points. That's what like Cloudflare and the others will be doing, but you can also run it on your individual web servers. So if you aren't using or you can't be using some large content distribution network, you can actually do this type of content inspection on your web servers on them themselves. And of course, you can then do DDoS filtering appliances and things. Now, the location of this has different pros and cons. So here we're looking at on-prem DDoS filtering. So here we've got, the internet as a cloud, of course. You've got your border routers, you have some internal routers, and then you have the actual target of the DDoS attack. So in a typical, dual upstream connection like this, the attack traffic is, of course, saturating your upstream links and attacking the target. So even if you had legitimate servers over here, they would have trouble getting access because the upstream links are being saturated at this point. So if we move it over and put in a DDoS appliance here, what you're doing is you're taking all of this attack traffic, inspecting it at this point, and protecting the endpoint. Now, this can be useful for connection-based attacks because the connection-based may not be saturating the bandwidth here, but it would be filling up the connection table of the target. So the DDoS appliance allows you to do more of that content inspection. It allows you to put TLS keys onto there to decrypt the traffic, look at it, filter out, and do what is needed at that point. The downside, of course, is that is usually a physical machine that has to be on your network. So you've got capital expenditure costs to purchase the machine. You still have bandwidth limitations. You're not increasing your bandwidth here, and you're not protecting your bandwidth here. You're protecting connections. And running a box like that does require some technical expertise. So protecting your network against bandwidth exhaustion attacks, this is where you can do some different things. The previous was connection-based. This is now bandwidth-based. You can do proactive rate limiting. This is where you can look for types of traffic that are, common with attacks. So fragmented attacks where they're sending fragments that then are causing CPU time for reassembling fragments on the destination side of things. Non-initial fragments, you can do rate limits on them. So we're not saying block them completely. Weird packet anomalies happen on the internet, but you can rate limit them so that if it's not an attack, they still go through as long as it's below the rate limit. Rate limiting traffic from commonly abused or unwanted ports. Again, a lot of that UDP traffic is going and getting thrown against you for things that you don't normally request. So that DDoS attack traffic might be abused in unwanted ports. And of course, you can be reactive. So when you see an attack coming in, you see the bandwidth being utilized on your network, you can go through and do rate limiting from less critical network locations. Depending upon your organization and how you operate, this may be a matter of looking at the geographic location of the source traffic. Say, for example, here in Pakistan, if you're servicing primarily, higher education, you may have local customers, students, however you wish to call it. If you're seeing a lot of attack traffic coming from outside of Pakistan, you can do rate limiting on that international traffic while providing full capacity for the domestic traffic. That may require additional links so that you can actually move traffic over to different upstream links, but it's possibilities that you have. Looking at some graphics for this, one of the ways of doing this is remote triggered black holing. This is where you actually are using a router or device that speaks BGP, and you can have this off to the side. And when you see the attack traffic coming in, you can actually use the trigger router to contact your upstreams and say, hey, traffic from these certain sources, send that off to the bit bucket. Don't route it through. So what we end up with, instead of that attack traffic coming all the way through down into your network, it is limited to your edge routers. The downside, though, is that usually what this is going to be doing is black holing the target, whatever that /32 was, and saying, don't route traffic to that server. So you may end up losing access to your target service, but the rest of your network is still operating fine. And that's a bit of the trade-off that you may have to make for it. If you can do it based on sources, that's a little bit better, but it's usually based on the destination. Another one, instead of using remote triggered black holing to your edge routers, if you have an agreement with your upstream internet provider, you can actually go and do the triggering to that router. So what we have here is the trigger router is sending the command up to ISP-A and saying, hey, don't route to this server that's being attacked. Now your bandwidth is rescued here. You know, you're not seeing the bandwidth attacks here. The bandwidth attack is still coming to your internet provider, and they probably won't be very happy. But at this point, the rest of your network can continue operating except for that one end server. It does require communicating with your internet providers and your upstreams beforehand to have this agreement in place. While you're under attack is not the time to be trying to do this. They won't want to talk to you because they'll be dealing with the same sort of DDoS traffic happening at the same time. Oh, this is just an extension of the previous diagram. So yeah, so here you have the botnets that are sending in the traffic. ISP-A still sees the attack traffic coming here, but it doesn't pass it down to your network. So ISP-A is still not very happy in this point in view, but your network is rescued. And then, of course, you can set up Anycast. So whatever target service it is, running up multiple of those servers, putting them geographically dispersed around the internet, so that when you have attack traffic, instead of all of this attack traffic coming through to one connection down to your target, it distributes the attack traffic as well. So if you have, say, this target is in North America, any of the botnets that exist in North America will send their traffic to the local target. It won't go across because the Anycast routing will take it local for whatever that geographical traffic is. So here, ISP-A is actually rescued as well. Moreover, if this target can handle this amount of traffic, then you won't actually have a DDoS attack. It will still be able to manage the amount of traffic. What it comes down to is having more of these targets spread in more geographical locations. And that's exactly how the large internet services are doing things, is they're spreading them out so that if they ever do get attacked, the attack traffic is distributed and therefore divided down and more manageable to handle. And instead of using Anycast and doing it yourself, of course, you can use the cloud DDoS filtering and scrubbing solutions. They already exist in multiple points geographically dispersed around the internet. And here you have the attack traffic coming in, but there's smarts to it. Instead of just passing it to your Anycast address, they actually do inspection. They know what DDoS traffic looks like. They know where botnets are. They can see the sources. They can see the traffic, and they can actually filter out the malicious traffic coming in. That leaves then only the good traffic, which may come from similar sources, but being actual legitimate traffic, and that can still come through to your target. So ways to protect your services from attack: Anycast, DDoS protection, and just overall network architecture and service architecture for how it's going to be done. That's the protection that we're looking at there. What we also need to look at, though, is how can you protect your services from being used to attack other people? And this is the whole social community of the internet. We can't just send all traffic from our network out to the internet without having consideration for what could be malicious traffic leaving our own networks. So we can do rate limiting, specifically on ports and protocols that are being used for attack traffic that are very common for that, but rate limiting the traffic leaving your network. Also, another common one, BCP38, or best common practice number 38. This is about outbound filtering or source address validation. Remember, I talked about the spoofed IP addresses and UDP packets. That's because the sources of those networks allow spoofed packets to go out. In legitimate communication on the internet, spoofed packets should not exist. Spoofed packets are only for malicious DDoS purposes. So if you are running a network and you know your IP address ranges, You should not be allowing traffic leaving your network with a source address that is not your own IP addresses. So normal packets leaving your network would have your own IP addresses as sources. You should not be allowing these spoofed packets out of your network. Additionally, if you're running DNS servers, which everybody does, and if you're running NTP servers, many people do, and if you're running SNMP servers, many people do, configure them correctly. If you run a DNS server that is a recursive server, a resolver, and it's publicly accessible on the public internet, your DNS server can and will be used to do DDoS traffic against third parties. You are basically aiding and assisting criminals in doing DDoS attacks. If every recursive server, DNS server on the internet, was blocking public access, then criminals would not be able to use DNS for doing that sort of amplification of traffic. Same thing with NTP. If all NTP servers were up to date, patched, and configured correctly, the amount of amplification would be very small and not worth it for DDoS criminals. Cool. So that's the DDoS topic. Any questions on that? Yes, sir. Oh, I forgot to mention, I have some gifts up here for people that ask questions. So I've got some small little carry bags, and I've got some larger carry bags, and a couple of notepads as well. So you get to pick which one that you want. So yeah.
Thank you so much. I have a question that you mentioned that there is a black hole technique, right? Sorry, the black hole where you actually don't allow the target server to access. Now, actually, the DDoS has a target that they put down the services. So I think the target is already achieved. If you just block the server, then target is achieved. They actually put down the server.
So yes, from the attacker's point of view, they have successfully taken down the service. But what we're talking about is sometimes called like a blast radius or noisy neighbor sort of thing. If they can deny access to one service, that's their mission. But if they deny access to your entire network, then that's collateral damage. You may want other parts of your network to still be operating. If they can deny access to your entire network, that means clients on your network can't go out and access legitimate things. So while they may have been trying to take down your web server, maybe they disagree with your political views on your website, so the attackers will go after your website. But if they, in the process of doing that, take down your entire network, then a lot more people are going to feel the pain. So they're actually causing a larger denial of service than what they were expecting, which from your perspective is a bad thing. From a managed service provider or a hosting provider, this is where basically an attack against one customer takes down all the other customers as well. So if one customer is under attack, you can basically say, I'm sorry, you're under attack and you didn't pay for cloud scrubbing services. So I'm just going to shut down your entire network here so that this customer can still exist on the internet. Because why should this customer be punished for an attack against this customer over here? And it's the same thing. If this is your web server, why should your clients on your network be punished because the web server is under attack? So yeah, so their mission is one thing, but the collateral damage of taking down your entire network is another. You know, in the example where I had ISP A up at the top, if ISP A was the DDoS attack, destination, then your network would suffer because ISP A was under attack, which would be a bad thing. But yes, would you like a notepad, small bag, large bag? You feel free to come up and choose from up here. Any other questions? Yes, sir.
Thank you. My question is like, how can we defend a large DDoS attack initiated from botnets from different sources? So could you explain it?
So the botnets from different sources is all about what type of service are they attacking. If they're attacking your routers, like specifically to the IP address of your router, there's not a lot that you can do other than trying to get filtering of traffic upstream. But if they're attacking a service, like a web server, having multiples of that web server allows you to spread the attack traffic out. So that's using the Anycast or using a cloud scrubbing service, Cloudflare, Imperva, AWS and Google and Amazon, they have them for their cloud-based services as well, where the actual traffic gets inspected and they use their view of the entire internet to know what is going to be malicious and then dropping that as well. So having these cloud scrubbers in front of your traffic can provide you that sort of assistance. Or if you're not using cloud scrubbing at the high end, having redundant servers that can be spread out, and that way the attack traffic can't attack all of them at one time. So if it's Anycast, for example, Anycast uses, say, a single IP address, but having many servers on the internet using that one IP address. But when it comes from different sources, they'll be attacking your IP address, right? But because there's only one IP address, the IP address in North America will get the attack traffic from North America. The IP address that's in Europe will only get the attack traffic from Europe. So now you've got a large sources all around the internet, only 10% attack here, only 10% attack here and there and there and there. So hopefully by having a smaller number of sources, your service can actually handle that amount of traffic. And that's where it's then configuring your servers to have more bandwidth, to have load balancers, have redundancy, have that scalability, as well as your tuning of your TCP/IP stack so that the connection table can't be filled up as well. Yeah, good question. Yes, sir.
Hi, Jimmy. Thank you so much for a wonderful presentation. And I believe whatever you told us, it was very nice. And we got a lot of things, especially in mitigation. So actually, I have two questions. Number one is, whenever we identify some legitimate and attacker in the sense of DDoS, so whenever we have a lot of requests from legitimate users, sometimes we announce some results on some websites. So in that scenario, we have millions of users accessing the same thing. So how our web server or our system ISPs can identify that either it's a legitimate request coming from users or it's an attack? And my second question is, I was wondering to see that you told something about the attack prevention system that is, I think, in Windows, if I don't forget it, to decrease the weight. So if there's a legitimate user and if you decrease the weight, so don't you think that if we decrease the weight, legitimate users also suffer from it?
So I'll answer backwards. So the legitimate users, we're talking about connections that are being established and communicating. So even a user who is on a dial-up modem, 32K bits per second sort of thing, they're still going to be sending traffic. Even the slowest connection from the opposite side of the world, they're still going to be sending traffic. And that traffic will finish within seconds. So even if you allowed a 30-second window, we're not talking 30 seconds for all traffic to finish. If they're streaming a video, the traffic will be seen as open. But what we're talking about in that tuning configuration point is that when the last packet is sent for the connection is held open in case they want to ask something else. So if somebody has made a request to your website and they have loaded the HTML, they've loaded the style sheets, they've loaded the images, you can close the connection at that point. And that's what that is talking about, is closing the connection after the data has been finished. By default, it holds it open just in case they want to ask for another web page. If they want to ask for another web page, they can set up a TCP session and they can request that other web page. Sure, it means they have to do another three-way handshake, but on the server side, you are freeing up your connection table, because holding a connection for 5 minutes by default is a very long period of time, just on the possibility that the client will come back and ask for more. So no, we're not talking about cutting off connections in the middle of data. We're talking about once the data has finished, close it off. But there's a lot of higher level protocols, like Quick 2, for example, and Quick. These are meant for opening up connections and starting transferring data very quickly, thus the name Quick. So it's not as much of a problem closing off connections, as soon as it's done, because then they'll just set up a new connection and send the request through that. So no, so it's not too bad. The other question that you're asking was around, which, sir? Yeah, no, the first question around sources of traffic, was it, or? Yeah, so when you have the multiple sources for the DDoS traffic, if it looks legitimate, then if you're using cloud scrubbing or load balancing or, smart application firewalls, they won't see it as malicious traffic. They'll just see a lot of regular traffic coming in. At that point, it's scaling your services, making sure that you have enough services that are running so that it can actually be supplied. So if you're in cloud, you can do auto scaling. Once one server gets busy, it will automatically launch up another container, another virtual machine, and spread that out behind the load balancer. The load balancer will then see the additional servers and spread the load between them. So yeah, so that's just capacity building. If you're expecting a surge or a spike of 1 million different clients coming in, you have to make sure that you supply that. There are some ways that you can do offloading, of course. So if you think about a website, the web HTML might be dynamic, but the images are usually quite static, assuming normal images. So what you can do is you can actually offload your static content to a content distribution network, one of those large services that can spread it out all around the internet using a different subdomain. So if you have maybe, images.domain.com, and you serve all of your static images off of images.domain.com, you can then put that to content distribution networks and have those images cached all around the internet and have them available. So now the only requests that are coming to your servers are for the dynamic HTML aspect for it. And that reduces it, because now I just say, give me the HTML, and you give me the HTML. And then I go over here for the images, and I go over there for the videos, and I go over there for the style sheets, but only the dynamic content is coming from your servers. So you can spread that out. So that takes a little bit of redoing of your website, knowing different subdomains and how to spread that out, so that no one point can get attacked as easily. Well, attacked by legitimate users. So. But yeah, so that's a common way of spreading that out. Yes, sir. Yeah.
I have a question from your last slide. You mentioned securely configured DNS. How we achieve it? Should we configure it on premises, or we need our service providers help?
Let me just get my slides back up for a second here. Did I still have that? There's my last slide. So securely configuring these, this is actually setting them up so that you know the traffic that's coming from them. For example, there were vulnerabilities in some of these. So the secure configuration may be just patching and updating the software. The resolvers is sort of similar to this. The resolvers is configuring so that it only listens from your network's IP addresses and not publicly. But for these ones, it's usually around what is visible to the internet. SNMP, for example, SNMP usually is not needing to be accessible over the internet. That's a local network management protocol for polling your routers, firewalls, and other devices. NTP needs to be kept up to date and not having that monlist command. Monlist is the one that was being abused. And for DNS, it's partially the network resolvers, but it's also making sure that you know who is contacting your DNS servers and having your network filtering in front of it as well. So knowing who's going to be talking and how that's going to be used. But for the DNS, it's mostly about keeping it up to date and having your network access control lists in front for recursive. If you're running an authoritative DNS server, the authoritative servers are, of course, publicly accessible. They have to be, that's how they operate. But you can also offload your DNS. You know, there are many companies that allow you to host your DNS on redundant servers on the internet, and they make sure that they have the DDoS protection so that you're not contributing to a DDoS attack, as well as not being targeted for a DDoS attack. Yes, you mean like DNS? Yeah, so DNSSEC for security for DNS, that is different. And that's talking about adding hashing to make sure the integrity of your DNS is kept. So yeah, so that is a different thing. That it's good to have, but the DNSSEC won't help you for any DDoS attacks. The DNSSEC is to stop people from changing your DNS responses as they go across the internet. Yeah, good question. Yeah.
Thank you so much. This is Sagir. I have a question that, for example, nowadays it's a very controllable environment on the internet. For example, there is a new movies are coming, and we are unable to watch it because their teams are always, shutting down on a YouTube and so on. But like IP tracer and IP booter, they are searchable very easily, and we can get the $100 and $200 to attack for someone. Why not the state or some of the teams are continuously working on them to shutting down, and why they are publicly available and this kind of thing?
Good question. So the stressors and booters, it's basically, for those that aren't familiar with stressors and booters as commands, it's essentially DDoS as a service, where the criminals are providing a service where you can purchase a DDoS attack and have it sent to any one person that you want. Why does any criminal activity exist on the internet? Because there are some internet providers and hosters that are not friendly, or they're not responsive to law enforcement requests. They do exist. Those services can exist in many places. So when you get to the actual criminal activity, they are operating in countries or using services in countries that will not respond to law enforcement requests. So at a simple level, that's why that's existing there. On a technical level of why DDoS still exists is, the things that you saw about here and here, DNS servers are configured. There are tens or hundreds of thousands of them on the internet. Some people are running old NTP time servers that allow amplification. Some people haven't fixed or patched their memcached servers. All of these things are technically adding to the capability for attackers and criminals to execute a DDoS attack. So when you have a technical infrastructure across the internet that allows DDoS to exist, and then you have criminals that are operating in countries that do not respond to law enforcement requests, you have that perfect combination. The criminal can do things without being prosecuted, and the technical infrastructure is supporting them to do DDoS attacks. From a very basic and naive point of view, maybe, when people are running these open services that contribute to DDoS attacks, when they are notified, they are possibly busy. They have other things to do. If they say to their manager, hey, boss, we've got this request that we are contributing to DDoS attacks. If the manager says, well, are we being attacked? Well, no, we're not being attacked. Is this harming us? No, it's not harming us. Is this going to take your time to fix these services? Oh yeah, boss, it could take me like a day to research and a day to do testing and then a day to roll it out. That's 3 days of time. He's like, is that going to make us more money? Is that going to get us more customers? Is this going to be better for our business? Well, no, it's going to stop us from attacking other people. But does that impact us? Is there a law against this? Will the police come if we don't? Well, no, there's no internet police, right? So for a lot of people on the internet, they are running these vulnerable services. They might not be told that they're vulnerable, or if they are being told, they may not be listening, or they may not have time to actually resolve them. And that's the hard part. This is a community effort on the internet to make things better on the internet for everybody. And it's the matter of doing things differently on your network so that you are a better member of the internet community. And we all have to recognize that. We all have to recognize that if I contact you for your network and say, there's bad traffic coming from your network, trying to do something about it. Yeah, absolutely. You know, if I notify you and say, your server is misconfigured, here's some, here's some websites and that, finding the right people on your network, finding the technical people that can understand it and give them the time to fix it up. Because if we don't operate as a community on the internet, if we all operate as individuals, then no one person is going to care until they're the victim. And then they're the victim from 100,000 computers out there on the internet. Oh, my boss is asking questions now.
Sorry, Chiu Chen, APNIC. I just want to add one point. There is actually potential reputation issue if people like tell you that you're operating an open NTP server as an MP server and you don't fix it, then you have potential reputation issue. Although you may not lose customer, as easy as like that, but like, I think you still have issue. So you have to fix it. You still have to fix it.
Yeah, no, absolutely. But the unfortunate thing is when it comes to reputation on the internet, that there's no central point where people can say, this is a bad network because they support DDoS attacks. There isn't any of that central point. With spam, we have spam filtering companies, right? Spamhaus and all of the others, where you can subscribe to their spam blocking list. But we don't really have a blocking list for not talking to DNS servers, right? But then it's not even us, it's the criminals talking to it. So, the criminals have this beautiful website that they can access that lists all of these misconfigured servers on the internet, but the individual people are not doing anything about it. And this is the community aspect for things. And this is why whenever at APNIC, we talk about things and we say, well, should we tell people that something's wrong on the network? Well, yes, we should tell them privately. Because a lot of companies do not want to publicly name and shame other companies that you're not doing things right for DNS, you're not doing things right for NTP, and we don't want to be the ones, not we specifically, but any one company doesn't want to be the one to shame other companies that you're not doing things correct on your network. It's hard. It's a global community and it's a global problem. But it's for this type of DDoS traffic, there's no single point like spam filtering for doing that. But all I can say is that if you do receive messages in the future that say you have a problem, take it seriously, do the investigation. If it is real, work for ways to improve your network. Yes.
Thank you, sir. Taking on your conversation, the responsibility of social, of the internet. On your last slide, you mentioned source address validation. Okay, sir. So, so it's one thing which the network which has not implemented is not affected, but other can be affected. So, as you already mentioned, that if someone tells us that it's not implemented on your network, you should implement it. And our managers asks, how much time it's take, how it's implemented. And we, so my main question is coming to the point. They are mentioned BCP38, a technique, I think. So a quick overview, how it can be implemented, or just a quick overview.
So yeah, BCP38 as well, just to let you know, this was created in 1997, 95, something like that. So it it's not even new. But yeah, a lot of people aren't doing it. And you're right. It comes back to the thing I say before, is that it's a problem for other people if your network is not configured, but it's not a problem for your network specifically. So this is depending upon how large your network is, how many connections, how many IP address blocks, and how often things change on your network. But if you're running a very simple network, you've got 1 or 2 connections up to the internet, and you have a block of IP addresses and that doesn't change, it's as simple as putting filters on the edge of your network that says, inspect the source addresses leaving my network, and the source address must be one of my list of IP addresses. There's other things that you can do, source path filtering, where you can actually configure the routers and say, hey, the traffic leaving here automatically must do that. But you can do anything from manual inspection through to the automatic source path filter, reverse source path filtering to look at where traffic is coming from, especially if it's meant to be coming through other networks. Also, if you're acting as an internet provider with customer networks, so not like individual dial-up customers, but a customer network, is having filterings on that connection and saying, I will only accept traffic from you that matches your source IP addresses. And then if I'm accepting traffic from you, I will only accept sources from your source IP address range as well. Once it's configured and running, it's straightforward. It's pretty good, but it's that whole thing. It's going to take time to investigate it. If you've never implemented it before, to read up on the different functionality, what router technology you're using, what manufacturers, what's the configuration, going into a test setup, doing the testing, then deploying out in production, maybe communicating with your customers and things like that. The rollout time will take time to do it. But it basically will stop you from being a part or contributor to these DDoS attacks. Because botnets exist because individual computers get compromised with viruses, right? It's very difficult to protect all of your endpoints, to protect viruses from turning them into a botnet. But if you can protect the traffic leaving your network, then that's reducing the DDoS attacks out on the internet. So yeah, no worries.
Thank you for the nice presentation. I just need to inquire something. Like few years ago, social media company, they just got the DDoS attack, and the services was halted by for 2 or 3 days, and they was bid a loss of $7 to $8 billion. And I just want to the $1 billion company, they was just stuck into a DDoS attack. Was it possible? One thing, what could be the loopholes in their security patches or something like a DOS attack just get into the system and stuck all the traffic, and like 2 to 3 days that was not functional. And even nowadays, or just a few months ago, like if I'm permitted, like WhatsApp.
So yeah, so sometimes the numbers are inflated. So whenever you hear that there was a cyber attack and it's caused $5 billion worth of damage, it doesn't mean that the immediate damage or the loss of revenue over that outage was 5 billion. It could be that was 1 billion, and the other 4 billion is maybe future profit that they're projecting that they won't get because they may lose customers. So the numbers can be inflated, unfortunately, which doesn't help. You know, especially if one company gives you real numbers and another company inflates, you can't compare them. You know, it's apples and oranges at that point. The other side, how can this happen? Where is my numbers? It was all the way back here. I had some numbers. Oh, there's my numbers. 2.3 terabits per second. Hands up, be truthful. Who here on your network at the best of times can handle 2.3 terabits per second of traffic coming into your network? Okay, there you go. So that's how this can happen. and who here, put your hand up and be honest, who here is not using a cloud anycast provider like Cloudflare and Perva, who is not doing that massive DDoS scrubbing in the cloud sort of thing? So is anybody here not using Cloudflare or Imperva for your networks? Because that's another thing. And that's normal. I'm not saying everybody has to use Cloudflare. I don't work for Cloudflare. I'm not promoting Cloudflare. It's just everybody knows Cloudflare, so it's easy to talk about. Imperva, and there's many others like that, you know, Akamai and the others. But if you're not using one of these providers that can handle 2.3 terabits per second, then you can be DDoSed. And all it takes is somebody who really doesn't like you to then buy that. We're talking about stressors and booters, and you know, $100 you can buy a DDoS attack for a couple of hours. Well, you get a bit more money and you throw that much traffic at somebody. These are hard, you know, like you look at even 60 gigabits per second. There are some countries that cannot handle 60 gigabits per second, let alone any one of their businesses within that country with their internet connections. So yeah, these attacks are very big. They're very real, and can cause a lot of damage. Like this attack here. 1.2 terabit per second attack against DIN DNS was the dynamic and DNS service provider. It took down every company that was using that company for DNS services. And that was only 1.2 terabits. It was a few years ago, sure. But this is the thing, is that if you are not perfectly building your network with the layers of all the protection and using external companies, expecting this type of an attack every single minute of every day, then you could be the victim of it. And depending upon what you're running, all of those services would then be affected. And that's the power of these bandwidth DDoS attacks. Because it's just bandwidth, as long as you can have a larger DDoS than what the bandwidth is available, the DDoS attack will be successful. And that's why it sucks. This is the horrible thing. These DDoS attacks, going back to, you know, what was mentioned later, these DDoS attacks exist because people are not running these protocols correctly. You know, if these protocols are accessible on the internet, they have to be managed correctly. There's a lot of these that should never be accessible. You should never have NetBIOS out to the internet. You know, you should never have SNMP out to the internet. SSDP is debatable. Memcached, if you're running that publicly accessible to the internet, it should be patched, or just don't run it accessible to the internet. You know, and then the ones that are run to the internet, DNS, LDAP, well, maybe LDAP is a stretch, NTP and that, they need to be managed. They need to be configured correctly. A lot of these services are seen as very small, easy to run, and you configure it once and you just forget about it. You know, what's NTP? It's just a time service. People ask me for the time and I tell them the time. So you install it, you run it, you configure it, and then you ignore it because it doesn't bring in revenue to your organization. And you set it up and it was working 5 years ago. Is it still working? Well, yeah, people are connecting to it, but understanding the security aspect for these services takes additional time, takes that additional understanding, and takes that security mind. And this is the tricky part, is that if the person running a DNS server or an NTP server is just a network engineer, then they're going to be limited by their own knowledge of what things are going on. This is why more people have to be trained and understand security aspects. And this is why organizations need security professionals that can go across and audit all of the services, all of the connections, all of the configurations, and ask the right questions. It's like, hey, when was the last time we updated this service? Are you running the latest version? Hey, there was a vulnerability a few years ago. Have you made those configuration changes and understanding that security aspect? You know, when they talk about security being in demand, it's everybody having that bit of security in them. not just having dedicated security staff, but the demand is for security to be trained across all network engineers, all system administrators, all technical staff that have responsibility for things like this. And this is just DDoS. DDoS is a very, very small part of security. There we go. So yeah, it's tricky. It's hard. But DNS, like a DNS resolver, that's another one. You set it up, you configure it, you test it, and then you leave it alone for years. Has it been updated? Is there maybe new, better current practices on configuration for these things? We have to go back and revisit all of the services on our networks to making sure that they are being run as best as they can be. It's hard. DNS does not bring in money. You work for higher education. DNS does not bring in research grants. DNS does not bring in foreign students who are paying higher fees or things like that. And this is the hard part. I've worked for commercial organizations where the question is always, oh, you want to do a new project? What new customers is this going to bring in? What more money is this going to bring in? How will this reduce our costs? What is the business financial impact? So, we're unfortunately having to operate in that financial world. And yeah, unfortunately, there's no internet police that will come to you and say, hey, you're not securing your networks. So there you go. Oh, yep. Oh, hang on. He started. Here, I'll pass you this.
Oh, thanks for your presentation. My simple question is that you have talked about many mitigation strategies that can prevent the DDoS attacks and that can mitigate also. In your experience, which tool and which box is very good to configure all these attacks that it can be prevent them and mitigate that DDoS attacks? And which tools and which box is more good? And as you mentioned before in your slide that next generation firewall is also good, but you can mention that which is good one.
Yeah, actually there is one thing that I didn't put onto here. Let me just bring it up. Give me one quick second here. Oh, you're not allowed to have everything. Okay, let me bring this over to here. Okay, so we try not, and we, APNIC and myself in general, try not to advertise commercial products too often. That's why when I say Cloudflare, I'm not promoting Cloudflare. It's easy to say. This is actually a not-for-profit organization, and they offer some of these services for free to a lot of people. So this service, for example, is free. It's not a silver bullet. Nothing in security is a silver bullet. But this is basically a service that you can subscribe to and connect to. Remember I talked about remote trigger black holing? That if you're seeing a problem on your network, you can actually black hole that address. And you can black hole up to your border routers, or if you talk to your internet provider, you can black hole to that. Now, imagine that you could have an agreement with many large internet providers all around the world. And if you see attack traffic coming to your network, you can put out a broadcast to all of these large internet providers all around the world and say, block this traffic leaving your network. That's what this is. So this is remote trigger black holing on a massive community scale. So, and what this is that when you subscribe to it, you basically are saying, if anybody in this community asks me to block traffic leaving to their network, I will also block the traffic on the way out. So everybody working together, that if I'm seeing traffic to my network coming from you guys here and you guys here and you guys there, I can send out a message and say, hey, can you block traffic coming to this IP address? Not my whole network, but this IP address that's being attacked. Now, all the DDoS botnet on your networks are blocking the traffic coming in. And you guys, I tell you, hey, stop this DDoS traffic coming to my network. So you put blocks in automatically just for my one IP address that's being targeted. Now I've reduced the amount of botnet traffic coming in, and I'm not being overwhelmed by so much bandwidth or connections and that. So this service here is community-based. Everyone has to have a two-way working relationship. You can't just go in and expect everyone to block and you not to participate, because you're running a network as well. And therefore, if you have any bots or malicious traffic leaving your network, if someone asks, you block the traffic on the way out. And it all gets verified so that it can happen automatically. People can only request blocks for their own IP addresses. So I can't say block traffic to this guy over here. I can only say block traffic to me. So yeah, so it's that community, and you can only advertise your own IP addresses. And the more people that participate, the better it gets. Yeah. So yeah, so this is one of those things that you can do without having to buy things, without having to, pay for services and re-architect your network and that. It's a little bit of work in there. But yeah, really interesting. So yeah, Team Cymru, it's spelled differently. They're based in like Wales, so everything's pronounced differently. But yeah, UTRS or UTRS, the unwanted traffic removal service. Team Cymru in general has really good services to support network operators and network providers. So yeah, check out some of the products. If it costs money, I'm not promoting it. If it's free, I'm promoting it. If it costs money, always do a comparison and make sure that whatever you're paying is what you need and that it's the best service for you. But if it's free, it's a lot easier to make the point that we need to implement these free services or access to tools and things like that. Another one that you can have a look at. I don't know if I'm typing that correctly. There we go. Shadow Server Foundation. So remember I said that, you could be running open resolver DNS servers on your network, or you could be running NTP servers that are configured wrong. These guys, again, not for profit, free services, free, like very free, for network engineers and network operators and that. They scan the internet. They look for these open services and things that could cause not only you problems, but the rest of the internet problems. And you can subscribe to their reports. It's a nice big yellow button. You just go click, and you tell them your AS number, you tell them your IP addresses, you prove that you are actually a network engineer, and they will send you reports of problems on your network for free. How cool is that? APNIC actually does support them. We give them some funding to help them operate, but these are free services that are available. So Team Cymru, have a look around, browse through what's on their website. Cool stuff there. Shadow Server, lots of really interesting insight. The biggest thing here is those reports. And they email them to you. You can do API queries, but they email you CSV files. Open it up, read what's going on, fix up your stuff, go from there. But yeah, free is good. So if you haven't heard of either of those two, those are ones to check out. So that is, oh, there we go. Team Cymru for that one. Just teamcymru.com and Shadow Server. You can Google it, but it's shadowserver.org is their website there. Oh, what do you want, Chi here? I got to give him the mic. He's my boss.
I do want people here to be good citizens on internet, so that's why I mentioned that negative reputation. So don't operate open DNS, open NP server, SMTP server. But on the other hand, if you are actually doing something good. Like if you implement BCP38, you do pop-up filtering. I encourage you to do manners to at least declare you are running this, so that's a positive reputation for your network. Maybe Jamie should mention that a bit. That's all. Thank you.
Thanks, Chihu. Okay, and the one that Chihu is mentioning is Manners. This is not a product. Manners is a set of best practice for doing network routing. One of it is the blocking of that spoofed source addresses. And you can go in here, you can read the advice on how to do it, and you can actually join and you can say that, yes, we are following the advice, and you can actually have your company listed as, yes, we are doing the right thing, the little green check mark sort of thing. So yeah, Manners, manners.org is the website here. So that's another one to be having a look at there. Yeah, you can read about it in that. Even if you don't subscribe to have your company name put up there, it is the best practice for internet routing advice. Going beyond, I think there's like, is it 5 key areas or something like that? But it's more than just the source address spoofing, blocking, and that. There's other good things to be doing for network routing. Not all DNS related, but things that will actually protect your network, not just other people's networks. Yeah, is it lunchtime? Have I gone over? I don't want to stop you guys from having lunch too much. It is lunchtime? Yeah, it is lunchtime. Does anybody else have a question that they want to ask that will stop everyone else from going to lunch? Or do you want to just talk to me over lunch? Okay. So it is lunchtime. Sorry we didn't get on to the other subjects and everything, but I think we had some great question and answer and discussions on here. I am running a security session after lunch. It's on a specific subject, so it's not choose your own adventure and voting on things. So after lunch, if you have laptop computers, bring it to that session. It's going to be a little bit of hands-on. We're going to introduce you to some free virtual labs where you can do some things, but we're going to be talking about penetration testing and vulnerability assessment. So again, it's only a short little 1.5 hour session, but it's the introduction, and then we'll go from there. Additionally, I saw some people taking pictures of slides. I will be uploading the slides into the Sketch system. And if you don't see them appear, you can reach out to me in person or email me, find me on LinkedIn. I'm available in a lot of different channels in that. So please feel free to ask if you don't see the slides, but I will be sharing that slide deck out so you can have access to that. Cool. Thank you very much for your time. I'm sorry for holding you back from lunch, but please go enjoy lunch, and I'll see you out there as well. Thank you.